Welcome back everyone to another episode of the Dome series, and in this video we are going to begin adding the sky in our game. Alright guys, so first of all we are going to begin by understanding how we are actually drawing our sky. So I'm going to run make right now just to give you an overview of how it actually looks. So you can see if I go outside I can see the sky here, and you might be able to tell that this is kind of like a sky box. So we are basically using a sky box here. Now a sky dome might be more like a semicircle or a hemisphere or something of that sort, might be more appropriate for this sky, but I think, well, it looks good enough, so I think we can continue to use this for now. And you can see we basically have a sky box here, and we are going to learn how to generate this sky box as well as learning how to actually render it. So to do that, let's first of all understand how this skybox is generated and used inside of our render.h. I have got two new functions here. One is set sky texture and one is the draw sky function, and this just sets the cube map that is used for the sky, because the sky uses a cube map, and a cube map in OpenGL is basically like a six-sided texture. And we could render draw sky, which is the actual function that will draw the sky. Now the main thing that we need to understand is that for the sky we will be using a different kind of basically shader, so we'll need to have another shader. So first of all, you can see I've got an init skybox function and internal function in the render which we are going to be using. So we've got the vertex and fragment source just like we had in the earlier videos, nothing changed about that, but we have also got two new vertex and fragment sources for the actual sky shader. So now we need to understand how this works. So to start, you can see that we can see here that we have got version 330 code, then we have got layout, and we have got all of this. So you can see that here basically, so where we have got version 330 core, after that we have got our vertex attributes. We have only got one, which is the position. We do not need any other attributes for the actual skybox because the texture coordinates are determined by the position, so we don't have that. And then we have got texture coordinates which are given out to the fragment shader, and these are as vector 3s and instead of vector 2s, because this is a cube map. And we have got view and projection here, but we don't need the model matrix. So we have got our main function here in which we set the position, and here you can see we do mat4. We convert a view to a matrix 3 and then convert it to a matrix 4. Basically what this does is that it zeroes out the translation components of the view so that the sky appears large and it doesn't change as we move around the scene, so that it actually appears like a sky. And we store this in a variable called position, which is a vec4, and when writing we write it at xyww, which is some swizzling. Basically it means that our depth component, the z component, which is the depth value, is always going to be 1, which is helps to ensure that we can draw the sky at the end of the scene when it will work correctly. And we have also got our texture coordinates which are set to position. So yeah, all of that. And in the fragment shader we have basically got nothing too much different. We use texel fetch with our palettes. We've got the palette index and stuff here as well, but we've also got a u sampler cube, which is the actual sky, and we get the texture coordinate from that, convert it to an integer and use that as an index to our palette basically. So yeah, that's some basic stuff. And here we have got the other stuff for actually changing these things. So you can see we have got along with our program here that we had earlier, we've also got a sky program now which represents the sky shader, and then we've got a sky view location and a sky projection location which represents the locations of these matrices in the sky thing. And we have also got a palette index location and the sky palette index location here as well. And inside of render.init you can see we init the skyboxes and the shaders. And if I go under render set view, now here some things change, which is that since we use sky program to represent our actual sky program, when setting the view we need to set it with both our sky program and the normal program. We need to make sure that normally our the usual program is used, however when running the sky we'll use the sky program. So when we set the view we switch the program to the sky program, we set the view to that, then switch it back to our normal program and set the view. The same goes for the projection and the palette index. Of course for the textures we don't need to do that since they are bound to specific texture points. And in the set sky texture we just assign the GL texture 3 to that, and we use GL texture cube map for the actual type of the texture. And if I go to the render draw sky function, now this is one of the more interesting functions. So our sky consists of 36 basically vertices. So it's like a cube, so a cube consists of 36 vertices, and Well, the way we have it here is that we first of all set the depth function to less than or equal, because we are setting the depth to 1. This needs to be less than or equal to make it work correctly. Then we disable face culling, and then we use the sky program, and we bind the vertex array to the sky box vertex array, and then we draw the arrays. We don't use draw elements here, we just use draw arrays. Then we set the depth function back to gl_less, which is a default, and then we enable face culling, and then we use our default program. So basically, we set everything back to the default state after drawing the sky. And inside of init shaders, the only thing that has changed is that now we also set the stuff for the sky texture. So we get the sky vertex shaders, the sky fragment shaders, and the sky program linked. And then we get the sky projection location, view location, and palette index location, along with getting the actual palette location and setting that to 0, and the sky texture location and set that to 3, because that's the one that we are using. And then we, for the normal program, we just continue like we were doing earlier. It's pretty obvious, nothing has changed really here. And now we can go on to our init skybox function. Now in here we set the vertices. You can get this vertex data in the GitHub repo, the link will be in the description. And this basically constructs a 1 by 1, actually, yeah, you can say kind of like a 2 by 2 cube, because it goes from -1 to 1. So it constructs a cube that we use to render our sky. And then we just generate the vertex array, generate the buffer, bind the vertex array, bind the buffer, and set the data. And then we just go ahead and set the vertex attribute array, enable the first vertex attribute array at index 0. And we set the vertex attribute pointer to basically have only 3 floats, which is the actual position. That's the only attribute we have. And apart from that, nothing really has changed basically here. And yeah, that's pretty much it. That's all really we need. So yeah, that's pretty awesome in the render.c. Now we need to understand how the sky texture is actually generated. So for that, let's open up wall texture.h. Now since the sky texture is actually a texture and not a flat, so there is a sky flat called fsky1, which basically means that a sky texture is supposed to be drawn here. We don't actually draw that flat. So in wall texture.h, you can see we generate the text. We've got a new function for generating a textured cube map that takes a single texture. And if I open up wall texture.c, you can see that this function uses some clever stuff, so we need to kind of understand this closely. So first of all, we get the texture ID and we generate the texture, and we set it to be a texture of cube map. And that's some pretty obvious stuff. We set the parameters like we were doing earlier. We don't use the unpack alignment here. You can use it if you want. We don't, because most textures are power of 2, so this shouldn't cause any issues. Anyways, now let's get on to the real start of the thing. So we get the size. Now the problem is that for cube maps in Doom, all cube maps must be the same size, all faces must be the same size, and all faces must be square. So in Doom, sky textures aren't usually square, so what we do is we get the maximum of the width and height, which gives us the size that we actually need to use. And with that size we allocate an array called data of that size multiplied by size basically. And then we set the data by default to 0, and then we copy into the data and we use this index here. So we get the total size, which is the last offset, and we subtract from it the texture width multiplied by the texture height, which means that we basically kind of subtract the amount of space that our texture will require, and then we divide it by 3. Now the reason we do this division is because we want to kind of position it a bit above basically above the bottom of the texture, because if it's at the bottom of the texture it will look below the horizon, and that will look kind of awkward. So this 3 value is just chosen like arbitrarily. It doesn't actually match very well the original Doom, but I think it looks kind of nice enough. You can try to change these values and see different results. So if I, for example, change this to like 2, you can see that the texture should be displayed a little lower. So if I go ahead and run this, you can see that it actually displayed quite a lot lower, so that kind of looks bad. 3 I think looks decent enough, so we have it at that. And then we set actually the GL textured images. For cube map we do use GL text image 2D, but we use GL cube map positive x, negative x, and positive z, and all of the other directions as well. And do note that you need to set all of these in order to work. So basically we've got another mem set here that I haven't explained yet. The thing is that the part of the image that we don't want to render, we are going to, for below the sky, we can just leave it black, because that's never going to be seen by the user basically, because we are not going to be seeing below, but we are going to be seeing above. And for that we just get the first pixel of the texture, which represents basically what the texture's color is at the top, and we set all of the top pixels to be the same color using this formula. So this this basically means that all of the texture will be the same color, so it looks kind of like the sky is blending into that background. However, this isn't the most cleanest approach because you should try to implement some sort of blending, but for the default Doom skies it seems to work quite well. So we just set that here basically like that. And now for the positive x, negative x, and the positive z and negative z, we just use this data that we had generated. Now as far as the question of the y-axis is concerned, for the negative y we just set it to 0 because we want it to be black. However, for the positive y, which is above, we use the same pixel that we were using for the higher portion of the texture. So we use that so that it looks like the texture is blending in again, and we set the whole data of the memory to that, and then we set the positive y to that data. And that's basically how we generate the wall texture, generate a skybox from the wall texture. So now all that's left to do is to take a look at how this is organized. And by the way, I made a couple of changes to the coordinate system. I didn't show them in the video because they were pretty minor and not really something worth going into detail. So I just kind of changed some order of the view matrices and some camera direction calculation. And the main reason I did that was because I wanted this to match the original Doom, coordinate system. And the way we were doing it by negating the y-axis, that was working as well, but I thought it was less convenient. You can take a look at the GitHub repo and try to change that if you want, and it can work like this as well. Doesn't really matter that much. Anyways, let's get back to this here. So you can see basically the only thing that we are changing is that we are comparing without any case. So we are comparing in without case sensitivity. We are going to compare the texture's name for when we are looping over the texture to set the information of the texture, we compare it with sky1. If that's the case, then we set the render sky texture to the generate texture cube map of this texture. So we generate the cube map and we set the render sky texture to that, and that's pretty much it. Another change is that inside of engine render, after we are done drawing all of our nodes, we must do this in the end. In the end we draw the sky, and yeah, that's pretty much all we need to do. Now of course, as I said, we could do with some blending up here, but it looks decent enough on first view, and it isn't too bad, and you can see that the sky is being rendered correctly. Anyways guys, this is going to be pretty much it for this video, and I'll see you in the next one, and in which we're gonna look into a small problem. So you can see that we can see the other sector from here, even though we shouldn't be able to see that. It shouldn't be displayed from this side, so we need to kind of understand how to kind of stop those exits, for example the exit sector, from being visible from here. So we are going to look into that in the next video. Stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and